Now, to learn a little bit more about light energy and how light energy is connected to color, I'm going to read you guys a book called What Are the Primary Colors, written by my friend Danelle Hogan. So, when we think about the primary colors, we think about red, blue, and yellow. But actually, when we're talking about physics and we're talking about light energy, that's actually not the case. So why do we learn that the primary colors are red, blue, and yellow? This is wrong. If you ask a physicist what the primary colors are, she would ask you, are you talking about pigment paint or light? So what are the primary colors of light and pigment? Let's find out. Light, here's an example of a natural light source, is so brilliant. The light coming from the sun is white light. Using a crystal prism, we can refract or split the white light into the colors of the visible spectrum. And I'll show you guys that right now. So this is my crystal prism, and right now that light from the sun, that white light, is hitting it and causing a shadow and also some reflections. But if it hits it in a very certain way, refraction is going to happen, and that white light is going to be split into the rainbow of colors that you can see right there. And there's a few different beams coming off. The colors that we see in that order are red, orange, yellow, green, blue, indigo, and violet, or an easy way to remember that is Roy G. Biv, the first letter of every color. No, there are not just 7 colors in a rainbow, but rather an infinite spectrum of colors. Our eyes just perceive those 7 very easily. Our eyes have cones to detect colored light. The cones are sensitive to either red, green, or blue light. Our eyes perceive red and green and blue light mixed together as white light. So instead of thinking of white light as the colors of the rainbow, we can explain it easier by just thinking of white light as a combination of red, green, and blue light added together. This means red, green, and blue light are the primary colors of light used in color addition. Those 3 colors coming together make white light in our eyes. Now let's look at the primary colors of pigment. They are yellow, magenta, cyan. When we mix paints together, it's called color subtraction. But why? Now remember, color addition was putting these 3 primary colors of light together to create the white light that our eye perceives. Now color subtraction is going to be a little bit different. Cyan paint. Our eyes see the color cyan when blue and green light enter it at the same time. You are seeing the cyan above because the paint is reflecting blue and green. What color did the cyan paint absorb from the white light? Can you guys see? These 3 colors went in. Red is absorbed into it, and blue and green are the only 2 that come out, coming together to make that cyan. Yellow paint. Our eyes sees the color yellow when red and green light enter to it at the same time. You are seeing the yellow above because the paint is reflecting red and green. What color did the yellow paint absorb from the white light? That's right, it would be blue. Magenta paint. Our eye sees the color magenta when red and blue light enter to it at the same time. You are seeing the magenta above because the paint is reflecting red and blue. What color did the magenta paint absorb from the white light? That's right, green. In other words, the primary colors are not red, blue, and yellow. They are cyan, yellow, and magenta. Let's make new colors by mixing the primary paint colors. Yellow and magenta paint mixed together create red paint. What color does yellow paint absorb or subtract from the white light? You see that blue is not reflected? What color does magenta paint absorb or subtract from white light? What color do both yellow and magenta reflect? And that would be red. That's why we see red when we mix those two together. This explains why mixing yellow and magenta paint creates red paint. The yellow paint absorbs blue light and the magenta paint absorbs green light, but they both reflect red. Now, cyan and yellow paint mixed together create green paint. What color does yellow paint absorb or subtract from white light? What color does cyan paint absorb or subtract from white light? And what color do both yellow and cyan reflect? This explains why mixing yellow and cyan paint creates green paint. The yellow paint absorbs blue light and the cyan paint absorbs red light, but they both reflect green. Magenta and cyan paint mix together to create blue. What color does cyan paint absorb or subtract from white light? What color does magenta paint absorb or subtract from white light? What color do both cyan and magenta reflect? This explains why mixing cyan and magenta paint creates blue paint. The cyan paint absorbs red light and the magenta paint absorbs green light, but they both reflect blue. So in conclusion, those primary colors of paint are yellow, magenta, and cyan. Just like if your parents purchase ink for their printers, they can purchase black ink or they can purchase the mixed color set, yellow, magenta, and cyan, because those three colors can create any other color we could possibly need. And the primary colors of light are red, green, and blue. Can you guys see that really faint rainbow that's in the shadow of my hand right now? That white light from the sun is being refracted by the water in the glass and splitting into those colors, the rainbow of colors. That is cool. Bella, this was supposed to be a science experiment. Now, it's one thing to read about color addition and subtraction, and it's another thing to see it in action. So I brought you guys inside, away from the natural light of the sun, and I closed my curtains, I turned off my overhead light. The only thing I have on is a desk light in my office, which I'll be turning off here in a second, so that we can see color addition and subtraction in action. So we learned that our eyes have cones, and those cones are sensitive to the following lights: green, red, and blue. Now, all of the color that we see are just our cones perceiving a mixture of these three in different ways. So I'm going to show you guys on my shadow board, and it's just a shoebox that I'm using the top of because it has a white inside. I'm going to show you guys those three colors and how they can come together to create other colors, just like we read in our book. Lights off. Okay, and here we have our green light, and here we have our blue light. And from our text, we remember that when the blue and the green come together, our eyes perceive that as cyan. And there's a couple different shades of it happening here, but it's kind of like a turquoisey blue when those two colors come together. A mixture of the green light and the red light. Do you guys remember what color that appears to be? It's kind of a surprising one. It actually makes a yellow. And again, you're seeing some different shades of it. The camera's actually capturing a slightly different color than I'm seeing with the cones in my eyes. but our green and red actually come together to make yellow, and blue and red, those two colors of light come together to make a magenta, which is more of a purple kind of color. When I add an opaque object, like a person or a paper cactus, to my light box, that's going to create a shadow, which right now with my white light is just a black shadow behind the white light. But if I'm using my color lights to create the shadows, it actually has a really interesting effect that I'll show you guys. So here's my blue light, which my shadows still appear black, my red light, and my green light. But once I start mixing those colors of light, watch the, I'll do blue and red, watch the shadows and how they change. Okay, so now my shadow is actually 3 shadows together. You guys see that? Okay, let me try green and red. And the further away from each other I move the lights, the bigger the shadows appear. And then I'll try blue and green. You can definitely see some yellow in that one. And then watch what happens when I put all 3 lights together. Can you guys make a prediction first on what you think it's going to look like? Let's see. And I want to see if you guys recognize the colors that we see in the shadows. Wow, look at that. So we have, let me get them lined up here. We have a cyan shadow, a magenta shadow, and also a yellow shadow, which happen to be the 3 primary colors of paint. Coincidence? I think not. For my demonstrations, I wanted to show you guys up close what I used. It's all pretty accessible stuff. For the red, green, and blue lights, they're just tiny little LED light bulbs, which are incredibly inexpensive and last a long time. And then I just taped little lithium cell batteries to each one. So when it comes to lithium cell batteries, it is important that you get them lined up correctly. When they are attached, they have to be attached on the correct side to make sure that the circuit is complete. So 3 little lithium batteries, 3 little LED light bulbs, and then I created my shadow box just with index card paper, tape, and a shoebox. So with a shoebox or another kind of box, it does help to have a light inside. You can do all kinds of light experiments. So I suggest that you guys do whatever flashlights you have. Maybe you have a white flashlight, maybe you have a black light that you can go see scorpions with outside. Play around with them, see what properties of light you can observe. So in conclusion, the primary colors of light are red, green, and blue. And a combination of those 3 colors of light, the cones in our eyes, are how we perceive all the beautiful colors around us in our world. And the 3 primary colors of paint, which can create any other color, are yellow, magenta, and cyan. So now you know. Bye, scientists. Now, since you guys are light energy experts now, I have a STEM challenge for you. Technically, it's a STEAM challenge because we've got a little bit of performing arts in there too. So my challenge is for you to use the engineering design process to plan and perform a light show for your classmates. So for this challenge, you must demonstrate either reflection, refraction, or the use of shadows in your performance. You must tell a story. It must have characters, a setting, a problem, and a solution. and it must be recorded. Your constraints are that you can only use materials you have around the house with your parents' permission. It cannot be shorter than 30 seconds or longer than 2 minutes, and you must have it ready to post on your class Facebook page by Sunday. So using that criteria, you guys are going to imagine some different characters, settings, and problems. Choose which ones you'd like to work with. Then go ahead and make your plan, design your story, and explain how you're going to be using reflection, refraction, or shadows. Then after your plan's complete, try it out. Create your performance, perform it, and definitely perform it for someone, perform it for your family, and record it when you guys are ready. Decide, did it work, or if you'd like to make some improvements. So I don't want to give any spoilers, but I'm going to give you guys like an itty bitty sneak peek of what I've got planned here. So I'm going to do a shadow board, but I'm going to have to turn my camera around so you guys can see it. Okay, so I'm going to do a shadow board, and just a little sneak peek. I'm going to have, oops, I'm going to have Mrs. Swartz and Mr. Swartz and our corgis and also Darth Vader. But that's all I'm going to tell you about that for now. So yeah, I hope you accept the challenge. I hope you give it a try. I can't wait to see your light shows. I'll post my light show, my performance, on your Facebook pages. And underneath mine is where you can post yours if you choose to do it. So super excited. Engineers, you got this. And yeah, have so much fun.